twin and single-seat carrier-capable variants were developed for the Indian Navy. The LCA's naval variant was intended to be ready for carrier trials by 2013 and was slated for deployment on the INS Vikramaditya as well as the Vikrant-class aircraft carrier. It will be equipped for carrier operation with the capability to carry out ski jump takeoff underrested landing. It will include strengthened airframe and landing gear, and the nose is drooped for better cockpit vision. The LCA, Navy, is India's first indigenous effort to build a carrier-borne naval fighter aircraft, a vital ingredient in the Navy's expansion plans. It is designed to operate from the future indigenous aircraft carriers the Indian Navy plans to acquire. It will use ski jump for takeoff underrested landing for aircraft carrier operations. The Naval LCA uses a drooped nose section for better view and strengthened airframe structure for aircraft carrier operations. The LCA Navy team from the beginning was aware that it would be a challenging task to develop a deck-based aircraft that very few countries have successfully negotiated, and which was being attempted for the first time in the country. At initiation, it was anticipated that the conversion of an Air Force version to a naval version with specific attributes would entail about 15% change. However, as the detailed design and development process unfolded, the teams involved realized that the changes were almost to the extent of 40% to 45%. Notwithstanding this, the maiden flight of the first naval prototype, NP-1, took place within 9 years of government approval, which meets worldwide standards. What this effort has also done is generate a considerable knowledge base in the country in understanding the nuances of carrier-borne aircraft design. In addition, a new leading-edge control surface, viz., LevCon, was introduced to facilitate reduction in approach speeds for deck recovery. Due to this being a first-time effort to design and develop a carrier-borne fighter aircraft, there was conservatism in the plan form, leading to a mass increase by about 400 to 500 kilograms. This is why the thrust available for deck takeoff fell short of mission objectives. It was thus decided that the LCA Navy Mk-1 would be only a technology demonstrator and utilized to conduct carrier suitability tests and demonstration. Having resolved the issue of sourcing material for the landing gear of the naval variant of the Tejas light combat aircraft, LCA, the Aeronautical Development Agency, ADA, slated the inaugural flight for late 2009. The naval fighter aircraft is a twin-seater variant with the nomenclature NP-1, Naval Prototype 1. It would look similar to PV-5, Prototype Vehicle 5. Of the LCA being developed for the Indian Air Force, IAF, though the naval aircraft will be powered by a more powerful engine. It will be a replacement for the British-made Sea Harrier jump jets currently used by the Navy. The Navy has placed intent to procure 40 aircraft. LCA Navy Mk-2. The Naval LCA project was approved by the Indian government in 2003, with the first stage of development comprising 2 LCA Navy Mk-1 flight test articles, a trainer prototype, NP-1, and a fighter aircraft prototype, NP-2, and a static test article, all built to the Mk-1 design. Since then, another trainer, NP-5, has been approved. Its airframe is under construction. In addition, 2 more Mk-1 fighter aircraft prototypes are planned to be built, although the Indian Ministry of Defence, MOD, is yet to formally fund these test articles. The second stage of the LCA project involves building 2 Mk-2 flight test articles, NP-3 and NP-4, both in a single-seater configuration. The concept design of the definitive Mk-2 version is understood to have been completed. The Mk-2 is, in essence, a major redesign of the Mk-1 for enhanced mission performance and improved maintainability. The Mk-2 will incorporate a more powerful General Electric F414 INS-6 engine as well as landing gear, arrestor, hook, and internal layout developments, a reduced nose droop to improve aerodynamic performance, and other drag reduction features. It will also feature a fuel dump system, increased fuel capacity, a retractable in-flight refueling probe, and an onboard oxygen generation system. The avionics suite will feature the new ATEM active electronically scanned array, AESA, multimode radar, an upgraded flight control computer, and an improved cockpit layout. Defensive systems will be enhanced with the new integrated electronic warfare suite. Crucially, unlike the LCA Navy Mk1, which was adapted from an Air Force variant, the LCA Navy Mk2 will be optimized ab initio to be a carrier-borne naval fighter aircraft, according to a project official. It is understood that the Mk2's first flight is now expected to take place around 2020. According to industry sources, the Indian Navy has a requirement for over 50 Mk2 airframes, to be formed into 2 squadrons. As stated in recent article in this article on IHS Jane. The LCA Navy Mk2 is being designed primarily to provide air defense to the fleet onboard carrier and meeting all the mission objectives set out by the Indian Navy. Significantly improved aircraft performance, largely better than Mk1, and integration of a full suite of weapons are capabilities inherent in the design. The main contributors to improvement in LCA Navy Mk2 have been identified as higher thrust engine, an increased wing area, an area-ruled and streamlined configuration, lighter landing gear and structure, and improved systems layout towards better safety and maintainability.